Hey guys, this is Harold L.R. Watkins back with another video. This is my AI Automotive Cybersecurity Incident and Compliance Assistant. The application helps automotive cybersecurity analysts, vehicle software engineers, diagnostic specialists, and compliance reviewers inspect vehicle cybersecurity incidents stored in a relational database. It combines SQLite, Python, Streamlit, and a grounded AI analysis brief. The database remains the source of truth, while the AI provides a controlled interpretation of the selected evidence. Here is my folder structure. You can see here. The application is separated into clear components. App.py for the Streamlit interface, db.py for the reusable SQL and database functions, AI.py for evidence formatting, prompt controls, and response handling, schema.sql and c.py for the database structure and rebuild process, data docs, and tests for the database documentation and automation validation. This separation keeps the interface database logic, AI logic, documentation, and testing independent and easier to maintain. Open up the schema. This database uses 7 related tables, which is uh, up from the top here: vehicles, incident controls, risk assessment, evidence, mitigation. Primary keys, foreign keys, check constraints, and unique constraints protect the relationships and prevent invalid values. The many-to-one control mapping allows one incident to connect to several compliance controls. I'm gonna open up c.py. This command rebuilds the database and loads 6 Ford vehicle cybersecurity scenarios. The the included database can be recreated entirely from the schema and seed process, which you see here. Moving to db.py. db.py contains all reusable database operations. User control filter values, use parameterized queries instead of SQL string um, concatenations, which reduce SQL injection risks. The join functions connect incidents to vehicle, VIN, ECU zone, and connectivity data. Aggregation functions calculate incident counts and average risk scores by severity. And the key AI retrieval function accepts one incident ID and returns only 4 evidence groups: incidents and vehicle risk content, map controls, evidence items, and mitigation actions. No unrelated records are sent to the AI. So you're going to see here, get connection, get all incidents, get incident by severity. Just to show a few. Moving to the Streamlit application, which I already have running here. The interface displays live records from SQLite, not hard-coded screen values. The join value shows each incident with the related vehicle, model year, VIN reference, ECU zone, and connectivity type. I can filter by severity, such as critical, and the application passes that value into a parameterized database function. So I can come down here and I can select incident. And come down here. This is where my summary is at. The summary section uses SQL aggregation and group by queries to display incident counts, average risk scores, control mapping, and the open mitigation queue. Okay, so I'm just gonna go back up here and I'm gonna select incident 3 actually. Let's go here. So in this incident, a Ford Mustang Mach-E telematics control unit scenario with a complete set of related records. The application displays the incident and vehicle context, tower information, map compliance controls, evidence references, and open mitigation actions. This exact evidence package is shown before before AI generation, so the analyst can inspect the source data first. The prototype does not open or parse raw artifact files. It uses the stored artifact description, metadata, and reference in the database. Didn't realize it's closed on me. Oh yeah, because I changed the incident. All right, so it's generating a new um, analysis. When I generate the brief, the application formats the four selected evidence groups, places them inside evidence boundaries, and sends them through AI.py with strict grounding instructions. The response follows 9 fixed sections: incident summary, affected vehicle, and ECU zone, attack vector severity rationale, risk source, risk score justification, map compliance controls, evidence status, open mitigations, recommended next action, missing evidence. See down here. The model must use the stored severity, risk values, terror notes, and recorded mitigation. It is instructed not to invent evidence or treat database text as an instruction. The missing evidence section is especially important because it identifies what the database does not yet contain. The AI output remains advisory and cannot modify the database or execute vehicle actions. For a closed incident with completed mitigations, deterministic logic prevents the model from recommending that a completed action be repeated. Prompt injection is also treated as a risk. Text such as ignore prior instructions is kept inside the evidence boundaries and handled as untrusted record content rather than as an application command. The application keeps the API key in a local.env file that is executed from source control and shared project packages. The automated suite includes 12 passing tests for record retrieval, parameterized queries, foreign keys, enforcement, missing evidence, selected record isolation, prompt boundaries, structured output, closed incident protection, and adversarial text contaminant. This down here, we have the option to, I'm gonna just open this, you guys. So we have an option to download our report to XML. And let me just this kind of out the way. I'll move this out the way. Come back here. And we also have, we can download it as text also. The professional value. This architecture has direct value in automotive cybersecurity, vehicle software engineering, diagnostic software verification, and compliance. A production version could help correlate incidents across VINs, platforms, ECU zones, software versions, diagnostic identifiers, evidence items, and corrective actions. The same evidence first design can also support other domains, including legal case management, where filing, discovery, exhibits, deadlines, and disputed facts must remain traceable to authoritative records. The current application is a controlled prototype, not an automotive decision maker. It demonstrates how a relational database can remain authoritative while AI provides a transparent and reviewable analysis layer. Thank you for viewing the AI Automotive Cybersecurity Incident and Compliance Assistant.